Let's talk about stream gatherers. Finally delivered in Java 24 under JEP 485. Gatherers extend the stream API with custom intermediate operation. It previewed in Java 22 and again in 23, and it was finalized without change. Now the motivation goes back to Java 8. A stream pipeline has three parts: a source, some number of intermediate operation, and one terminal operation. Java 8 shipped a fixed set of intermediate operation: map, filter, flat map, limit, sorted, and a few more. It also added collect, a terminal operation that accepts any collector implementation. So from the first release, you could write your own terminal operation, but you could not write your own intermediate one. And that didn't change for 11 years until Java 24. So let's jump into IntelliJ and put the two interfaces side by side, collector on the left and the new gatherer on the right. If you have written a collector before, this will look familiar. A collector has a supplier, an accumulator, a combiner, and a finisher. And a gatherer has an initializer, an integrator, a combiner, and a finisher. The same four roles. The initializer creates a state, the integrator handles one element, the combiner merges the state from parallel threads, and the finisher runs at the end. So they differ in three ways. First, they sit in different places. Collect is a terminal operation, so it ends the pipeline. Gatherer is an intermediate operation, so it returns a new stream, and you can chain more operations after it, including another gatherer. Second, the per element method behaves differently. In a collector, the accumulator returns nothing. All it can do is fold the element into state, but in a gatherer, the integrator takes a downstream and gives back a boolean. For each element, it can push 0, 1, or many, and if it returns false, it takes no more input. The third difference follows the second. A gatherer can emit output before the stream is exhausted, so it can work on an infinite stream. A collector cannot do that. It has to consume the whole stream before it produces anything. So let's look at an example, a running sum over a stream. The first version keeps the total in an array outside the pipeline and updates it inside a map. On a sequential stream, that gives the right answer. In parallel, it does not. Because map is a stateless operation, the runtime can run it on different threads, and they race on the shared array. The second version moves the total inside the gatherer. The third one runs the same gatherer but on a parallel stream, and it gives the same 5 totals in order. The gatherer is declared sequential, so even inside a parallel pipeline, the runtime keeps it in order. So here is runningSum itself. It declares 2 of the 4 components. The initializer creates the accumulator. The integrator adds each element and pushes the new total downstream. And since that push happens on every element, values leave this stage before the input is finished, which is exactly what a collector's accumulator cannot do. It is built with off sequential, so there is no combiner, and that is the declaration the parallel test relied on. Now, frequency is the other side of that. It counts how many times each element appears, and it declares all 4 components. This time, the integrator only updates a map. It pushes nothing until the finisher runs. The combiner merges 2 partial maps by adding their count, and the finisher pushes an entry for every distinct element once the input is exhausted. So this one is built with gatherer.off, and it can run in parallel. And that is the real difference between the two. A running total depends on the order elements arrive in, so it cannot run in parallel. Counting, on the other hand, is independent of order, so it can. Now you could get the same count from grouping by, but that ends the pipeline. This stays inside it, so you can keep chaining. Now the JDK also ships 5 built-in gatherers: fold, scan, map concurrent, window fixed, and window sliding. The documentation link is below. And the 2 gatherers we saw come from a library I maintain. Currently it has 12 of them, grouped by what they do: counting, deduplication, indexing, consecutive runs, windows, and math. It is on Maven Central under io.github.manoj.shr, and the source is on GitHub. and it is ongoing work, so if you need a gatherer that is not in there, open an issue or tell me in the comments. To recap, a gatherer is a custom intermediate operation. State goes in the initializer, per element work goes in the integrator, and a combiner goes in when partial results can be merged. Without a combiner, the stage runs sequentially.